Hey, how's it going, everybody? Thank you for joining us on our show. Hey, Jason, I am super excited about this one. We have an awesome show today. We always have an awesome show, but I think that this one in particular is going to be really great. But before we get into that, I'm Adam Bloom, Solutions Architect with AWS here in St. Louis, having some stormy weather. How about you, Jason?
Hey, well, Jason Stinson, Solutions Architect at AWS also. Yeah, it's been great weather. Actually cool today. It's been really hot here, so I'm glad to see the light overcast we've had. It's been awesome. So yeah,
Dude,
I'm super excited.
it's been so hot, hasn't it, Jason? Like, yeah.
Yeah, it's been blazing hot. So it's good to have a little cloud cover to block the sun. Yeah.
I'll tell you what's also hot. That's
Yeah,
Strands Agents, AWS
absolutely.
Strands, right? Like, we had, for you audience members, we've had the AWS Strands team here before talking about MCP, talking about different capabilities, but now we get to talk about multi-agent orchestration. We get to talk about even agent to agent, which is super exciting. A lot of stuff going on here with Strands and AgentCore and all things agents. So, Jason, what are you excited about, regarding
Yeah.
this?
I'm excited to see the demo. I'm excited to learn some more about agent to agent and strands as well. I'm looking forward to it. Yeah.
Yeah, because I mean, we've talked a lot about MCP this year, and MCP is so important to breaking down those data silos.
Yeah.
But agent to agent, I feel like this is such a even newer, more emergent agentic pattern that I'm just super excited to see in customer environments as we think about, okay, now we have our agents accessing tools and resources. What does it mean to look to deploy these agents that communicate to other agents? So
Yeah.
super exciting. So you ready to bring out our guest, Jason?
Yeah, absolutely.
Cool.
Hi there.
Hey, thanks. So Amanda and Akarsha, you guys want to go ahead and introduce yourselves?
Yes,
Definitely. Amanda, you want to go first?
sure. Hi, everyone. My name's Amanda. I am a go-to-market specialist at AWS, and I'm coming from Dallas, Texas today, and it's triple digits here. So,
man.
Oh my God.
Brutal.
How's that humidity? Is it pretty humid there, or is it just dry heat?
Dry heat.
Yeah.
Hi, everyone. My name is Akarsha. I'm a Gen data scientist and a part of the Strands GTM team. Well, it's not that warm here. I'm chiming in from New York, so it's quite humid, but not that bad. I think I've seen worse days.
Awesome. Well, thank you, Amanda and Akarsha, for joining. This is Jason and I were just talking. We're super excited about this.
Yeah.
Because you guys have a lot to talk about with agent orchestration and A2A, and also new agentic patterns that we're starting to see with the recent announcement of AgentCore.
Most definitely. We have a lot to share and very excited to share that with all of you and hope you will enjoy it as much as we did while building it.
Heck yeah, super. By the way, for those watching, feel free to ask your questions. This is more of like a conversational presentation / demo, so feel free to ask your questions. Amanda, Akarsha, you guys want to go ahead and get started?
Mm-hmm.
Yeah, Also, where is everyone coming in from? I'd love to see in the comments where everyone's joining from today.
Yeah, love to hear that too. So yeah, we could go ahead and get the presentation started. Let's see here. I'll get this going. Okay. All right.
Perfect.
Looks like we have it up.
Mm-hmm.
All right. So so for today, we're going to go through a little bit more about how the future of AI is multi-agent. And we're going to talk through and share a little bit more about how you can build multi-agent applications leveraging an open source framework for building agents using Strands Agents SDK. We're going to go through a deep dive into how you can leverage the A2A protocol to get more extensible use out of your agents. And then we'll talk a little bit more about how you can.
Hey, Amanda, your audio is coming through a little choppy there. are a little muffled.
Oh, can you hear me better now?
Yeah.
Okay, perfect. All right, so to get started, the one thing that I wanted to make sure that everyone is aware of is the fact that our AWS CEO, Matt Garman, just recently shared his vision of a technological shift for how we build, deploy, and interact with agents. We're seeing at AWS that AI agents are as transformative as the internet. And we believe that there will soon be billions of agents in the world that are going to be interacting alongside developers and humans to augment capabilities, to make teams more efficient and effective, and fundamentally transforming the customer experience, which is super exciting. And we're seeing this across a number of different sizes of organizations and different types of industries. And this shift for how we build and interact with software is going to fundamentally change how we interact and build with these applications. And it's going to change how the way that software is built. It's going to change how software is deployed, and fundamentally how humans are going to interact with software and the different applications that we use every day at work, as well as in our day-to-day lives. So it's really exciting time and space, and there are a variety of different ways that you can leverage these AI agents today when you're looking at building your applications. The first is for taking this agentic AI from hype to reality is the fact that there are incredible models that are available today for customers and developers to be able to leverage. These foundation models have more advanced reasoning capabilities than ever before, and they're offered with a wide range of cost-effective options. The second is the fact that these agents need to be able to ground their knowledge based on data, and being able to go in and integrate with various source systems of record. The third is the fact that these agents need to be able to communicate effectively. They need to be able to discover the latest and greatest tools and services, and they need to be able to connect in a safe and secure manner. And that's where these agentic protocols and infrastructure is gonna come in. And then the fourth is really around agent development and tools. So there's a large emergence of sophisticated tools and patterns to be able to design and deploy and manage those agents at scale. And we're going to cover today how you can leverage the variety of different models that access the tools and the agentic protocols to be able to get the most out of building your agents.
So Amanda, it sounds like what you're describing here is like a completely new vision, not just for chatbots, but actually for software. I mean, that's what we're kind of building these. AWS is kind of looking towards the future of software itself, I think, right?
Yes, and this is fundamentally what we're seeing is that AI agents are gonna be used as a way to drive more autonomous software systems. So in the past, when developers were building software applications, you had to go in and specifically define specific tasks and workflows, and it was very deterministic. And in this new world of agentic AI, you can leverage these agents to do this in a more autonomous way, and instead leverage the latest and greatest model reasoning capabilities to be able to have that AI agent reason, plan, and complete tasks in a much more autonomous, more efficient and effective way. So we fundamentally think this is going to change the way that software is developed, and it will drive more efficiency for internal teams as well as end consumers that are leveraging these various applications in their day-to-day lives.
And I think just the fact that we are right now trying to standardize the protocols, trying to standardize the way these agents communicate. I mean, remember when we had just had the Fast API for web frameworks, right? That was facilitating basically the creation of these discoverable interfaces that were available for external consumption. Now that's exactly what we are now doing with Fast MCP. So it's kind of, I think, moving along the same lines, but with the speed of light. Like it's going so fast. For software development, we have had like 30 years to develop. And in this, we are already pacing up that development that we've had seen, over decades. We've just seen this in a couple of years.
Yeah, Carson, this is like so exciting to me, and I know Jason, it's exciting to you too, and probably all of you listening here or watching rather. It's just like this idea that a lot of the core tools that we use to just transform data, to just visualize data, like that's all going to change. Like I just trying to think like once these agents proliferate, we have these standardizations, and you have the cloud scale at your fingertips. Like I just the applications, like I just think about like using office productivity tools. You could just upload your data to your agentic system that has access to your data and tools as knowledge bases and memory. And why do you as a human need to interact with those kind of archaic deterministic tools when the agents can kind of transform, visualize the data, give you insights, or take action? Like it just is just so exciting.
Yeah, it's gonna be incredible to see what developers build with this now that we have all of this technology at our fingertips to be able to do this. And from AWS's vision, AWS has been the provider that has been providing developers with a really strong foundation of security, reliability, operational excellence. And when it comes to agentic AI, we're doing the exact same thing from providing those core fundamentals so that when developers are going in and building agents and deploying those agents to production, we'll be able to provide those developers with the best place to build and deploy the most trusted and useful agents at scale and securely. So in terms of how we're helping to bring this vision to life, there are 4 key areas where AWS is simplifying these multi-agent patterns for developers and companies of all sizes to be able to go in and build these agents. The first is the fact that these agents are powered by inference. So by that, I mean they need to access the best foundation models and capabilities to support those specific workloads. And Amazon today provides Amazon Bedrock, which is an incredible service that allows you to go in and access the latest and greatest top performing foundation models to be able to accomplish your tasks. The second area for simplifying multi-agent patterns is around providing developers with the tools and frameworks to build agents in a very flexible, open way. And today we offer Strands agents to be able to accomplish that. The third area is all around making it easier to be able to discover, communicate, and collaborate amongst these agents. So agent-to-agent protocol is one of the ways that we're helping to make sure that when you're building these agents, you can provide the flexibility for those agents to be able to communicate amongst one another to get those specific tasks done. And then the fourth is all around providing the core set of services to be able to deploy and operate those agents at scale and securely. So we're super excited about the various services, and we'll go into detail today into how you can build these agents and get them ready for production deployment and start benefiting from this incredible technology as you're going in and building your various generative AI applications.
I think one more thing I want to highlight here is the tools and frameworks, like just the existence of that is not enough. Like the ability to extend them is very important, because every use case that we develop, every new industry that we look at, there are so many different things, so many different considerations that you have to look at when you're, using frameworks or maybe using the tools or building those tools. So that extensibility is a very important thing to mention here.
Yeah, absolutely. So let's dive right into the details here.
Yeah, of course. So in terms of Strands agents in particular, one of the things that we've heard from customers is that customers need flexibility to use different models depending on different tasks or different use cases. And to deliver this, AWS expanded model support within the Strands Agents SDK, so that when you're going in and building your specific agentic workload or use case, you can take advantage of the reasoning capabilities from a variety of different model providers. So we worked very closely with, and you can see this in the pull requests in the SDK, but providers such as Anthropic, OpenAI, Mistral, and Writer, made contributions to make sure that their model APIs can be used alongside Strands agents with code, and then you can also leverage any of through Light LLM. You can also leverage any OpenAI compatible endpoint to get the most out of your Strands agents. And then lastly, to further provide customers with flexibility, we also have support for being able to bring in your custom model provider as well if you have a specific model that's not necessarily provided from within the stack.
Cool.
This actually is one question that I hear a lot, which one do I choose? Which one is better? And honestly, this development of so many frameworks isn't new, right? Like we were talking about programming languages just now. So over the last 30 years, there were multiple programming languages that emerged. And each one of them was catering to the needs of a specific group. So for instance, there was Objective-C, and that was great. This was the primary language for iOS, but there were still some limitations. I think every framework, every service has some, right? So Swift was developed. And similarly, into the agentic world, it's on you to understand what limitations apply to you or the use case, and which ones don't really affect you. And with this Strands Agents SDK, we essentially try to address the cohort of customers who want a more flexible, a model-first framework. This way, they can implement their agents, but with less code. So that was the main target here.
Yes, and AWS went through an open sourced Strands agents to provide developers with that more flexible set of tools for developers to be able to go in and develop and build these agents in a more fast pace in terms of innovation. And you can see here in this screenshot, when we say there are a few lines of code, this really is the total amount of code that you need in order to import an agent, leverage Strands tools, and then to be able to make a call to an HTTP request. This is the total amount of code that you need in order to make that agent happen. And the key benefit here for developers is being able to go in and quickly leverage the SDK to be able to build faster, so you can get innovation out the door. And that is going to be really key in this rapidly evolving landscape.
Mhm. But isn't this amazing? I mean, we talk about web search agent so commonly, right? And it's so often being used by customers or users. And this is essentially it. I mean, if you want to build a web search agent, you import the HTTP request tool, you have access to the web, you ask the question.
Yeah.
Simple and easy to go.
Yeah, Karsha and Amanda, like this is something I've heard from my customers that they love LangChain, they love LangGraph, but once they try Strands, they're like, oh my gosh, it's so much easier. It's just, I'm impressed with how easy it is to use Strands. In fact, I had like a proof of concept demo that I was working on for like text to Sparkle using, built the MCP server for that. And originally I was not using Strands, and then I converted my agent framework to Strands, and I was like, wow, this is like way easier than I thought it would be. And it allowed me to do some things that normally would have taken a lot longer. So I'm super impressed with Strands. I know my customers are too. And I'm just trying to get a lot of my customers like, at least try it. I mean, LangGraph, LangChain, awesome. But like Strands is really for real. It's the real deal.
And I am not a developer by any means. I did my first pip install. I went through and I was able to, it was so simple and easy to follow the documentation and the instructions. Once I got in there, I was able to go build my first agent as not even being a developer. And so it really is that simple and easy, even for those individuals who are just getting started for the first time, leveraging Python. So highly recommend going in and playing around with it.
Yeah, absolutely.
In terms of Strands, there is a number of different announcements that we just recently made at the AWS New York Summit, and I wanted to make sure that everyone was aware of all of the latest and greatest enhancements that are available today for specifically for building multi-agent systems. So Strands Agents is now officially in version 1.0. So it's generally
Congratulations.
super exciting. And with this release, we specifically added A2A support. We added 4 different multi-agent primitives and workflows to enable more specific multi-agent capabilities. And then we also announced some additional enhancements to make it these agents production ready. And all of these, again, were coming from the community, the open source community, and the hundreds of customers that we've been working with worldwide based on their feedback in terms of what is needed in order to not just build a single agent, but how do you build these agents, multiple agents at scale, get them ready for production? How do you make sure that they're communicating effectively and using the latest open source protocols? And we'll dive deeper into each of these particular enhancements. And the first of which is all around making sure that we're building these agents in a interoperable way. So one of the when you think about building these agents need to be able to leverage the variety of different tools and data sources to be able to address those questions from customers and take certain actions. And that's where AWS really has taken on and really leaned in here on making sure that it works with the MCP protocol as well as agent-to-agent protocol from a communications perspective.
Yeah, Amanda, think about it, right? looking at any real world scenarios that we've seen with our customers internally as well, we have so many teams, so many organizations within the full enterprise. We have every team owns their own data platform, their own data APIs, data sources, or other service APIs. And all of this is scattered around the organization. And ownership, of course, lies in different teams. I mean, no one person can handle it all. So it is so important to have a strong support for interoperability in today's world with agents running it, right?
Yeah, and Akarsha and Amanda, I was hoping we could like really get into a demo because but before we do that, I just want to say, I think a lot of us are, a lot of us here are kind of familiar with MCP, which is the way that we give our agents access to tools and data, which is so important. But now there's this A2A stuff, and agent to agent's a lot newer. I shouldn't say a lot newer. It's a bit newer than MCP, and it's not nearly as well understood. Do you guys want to talk about that just really quick on what that means? Because we have this open source model agnostic agentic framework in Strands. We've had the MCP built in, the MCP client built into Strand, which is so convenient. And now we have A2A. So what does that mean though, from an agentic like enterprise architecture?
We have it ready. Okay. So I think taking an analogy, maybe not the best one, but think of an enterprise, right? We have every enterprise has created a standard way of communicating. So for instance, for communication, we have a service that manages the calendar, right? Otherwise, how confusing it would be if, your colleagues are calling you on Zoom, on Teams, or Slack. It's probably a bad comparison, but this is an example of why we would need, a standard way of discovering, of communicating and collaborating with each other. And similarly, in agentic world, this is A2A, allowing the seamless communication between different AI agents across, different platforms and different implementations. The implementations could be the first-party services, so your own enterprise services, or third-party services, so something that is managed by another provider, and you can give access to them via the agent marketplace. And
well,
yes.
Karsh, I just want to interrupt you there. We have a question. If you want to take this one, could we use multimodal models?
Multimodal models. We do support multimodal models as well. So we have the support for the. I'm missing.
Yeah, we have so the Olama is supported within Strands Agents. Any of the models that are available within Amazon Bedrock, we have a number of different multimodal models that are available there, from text, image, from Stability AI is one of those models that allows you to create professional grade images, and then you could also bring in additional multimodal models, even from a custom model provider support that you can integrate. So tons of, when you're going in and building your agents and you want to be able to leverage the foundation models for your particular use case that may need multimodal support, this is extremely flexible. So you can, and we're providing you the model choice, so you can build the way you want to build. To be able to address those multimodal use cases.
Thank you.
So, Jason, you have something? Sorry.
Yeah, I had a quick question. So this seems like a super powerful tool. It has me thinking, how do we secure that agent-to-agent communication between those different data sources?
Yeah, so one of the areas that AWS is really leaning in is we're actually on the steering committees for both the model context protocol, as well as working alongside the A2A project. So we're helping to define and make sure that we're improving those protocols to make sure it meets the needs of enterprises that are looking for security around and meeting this very specific requirements that customers are looking for when agents are interacting and communicating amongst one another. So from and these open standards are really defined by these steering committees and also based on feedback from the open source community to make sure that we're providing that full support within both MCP as well as A2A to enable more secure agent communication as well as interoperability in terms of the data sources and the tools that are needed in order for that agent to accomplish the particular task.
Okay, great.
Yeah, great question, Jason. And I think just to paint a picture for everyone that's watching here, what we're doing, right? And Amanda, Akash, you guys can just jump in, but I think what Strands is providing here is this really agnostic way to give tools and data and then agent to agent communication in one seamless framework, at cloud scale. And I think that this is, I just think about, like this idea of, if you're an organization and, you have all these data silos, on-prem and the cloud, wherever they are. Okay, now you have MCP to break those data silos down. But now you also have this agent to agent capability where you could be like, okay, maybe this team, they have their agents and this team, in finance has their agents. Well, now we want to automate workflows and have them talk to each other with AI intelligence. And I mean, correct me if I'm wrong, but I think that's what A2A is kind of giving organizations the power to do, right?
Exactly. Exciting, right? And it's so powerful. I mean, it's just so important to have this cross-platform integration. It's so powerful in today's world with, we have so many agents. And as Amanda was mentioning previously, we are hoping to have millions and billions of agents in the near future.
Yeah, I mean, that's super exciting. Is there a way we can jump to the demo and we can get back to the content after that? I think we're ready to see this in action.
We need a bit of context of what we are going to build.
Okay, no
so
problem.
We'll quickly go through the multi-agent system. So we've talked about the protocols, but what patterns can we build with it, right? So let's take a brief look at that. So Strands enables specialized AI agents to work together as well, right? Be it delegating tasks or sharing knowledge or coordinating actions to be able to solve, complex problems that one single agent probably cannot handle alone. So we have 4 primitives that we have introduced with Strands 1.0. Let's go into a bit more depth in each of them and see how they work. So first one is agents as tools. So these are specially made for hierarchical delegation and made super simple to be able to transform the specialized agents into intelligent tools, essentially, that the other agents can call, right? And this way, you can enable the delegation in a hierarchical format where the agent that is acting as an orchestrator that can dynamically consult different domain experts without having to give up control of the request. This kind of mirrors how human teams work. So think of a project manager who doesn't need to know everything. They just need to know which specialist they need to talk to consult for each task, right? Amanda, when do I use it?
Yeah, it's a good question. So I think in terms of leveraging these particular agents as tools, I would recommend using this when you're wanting to separate concerns. So when you have an agent that has a very specific focused area of responsibility, let's say you're an airline that is wanting to leverage an agent for handling ticket refunds for those travelers, you'd want to make sure that system can be much easier to understand and maintain, and you can use that agents as tools to make sure that agent has that very focused area of responsibility. And then the other area I think that where this would also be really good is when you're wanting to improve the performance of that system. So when you're leveraging these agents at scale, and you have multiple agents, you don't have one in the system, you may have hundreds that you're managing. You want to make sure that that agent has a very tailored set of system prompts and tools that are optimized to be able to accomplish a particular task. So when you think of that airline example, you may have a specialist that is a specialist agent that's focused on addressing ticket refunds, and another one that is very specific on making sure that the traveler is able to get their baggage appropriately. And they're good. And that baggage handling agent is going to have very specific tools and access to certain systems to be able to make sure that they're getting your luggage to you appropriately.
Perfect. Moving on to the second pattern. So this here we are talking about workflows, right, where we have explicit transfer of control. This enables agents to explicitly pass responsibility to another agent or even to humans. When they are encountering tasks that are probably outside of their expertise, and you still want to preserve full conversational context during the transfer, that's potentially where workflows fit in. So you're in a sequential format. You are transferring the information to the next agent. So I think in this case we can think of it as how different teams work together, right? So for example, applied scientists or data scientists develop the machine learning logic. They pass it on to the ML engineers to convert it to a production-ready code. And then MLOps engineers come in and deploy it and operationalizes it, right? So all of them have their own expertise, and there is a defined flow to it. So that's when this could be a really useful pattern to use. Do you want to highlight when do I use it, Amanda? Because
yeah, I think for when you would leverage handoffs in particular, what I would look at this in terms of simple tasks or highly collaborative problems, or where you need to make sure that the particular situation or problem is going to require handing off to that specialized agent. And the one thing I do want to make very clear is, like, as we're going through these different architectural patterns, you don't have to pick just one and go with it for your particular workload. You could actually, these are intended to be very modular, and you can mix and match these various agent patterns to make sure that you're addressing that particular use case. So when you're looking at trying to make a decision of which one to use, sometimes the answer is you may need to use both the workflow alongside Swarm or agents as tools in order to accomplish the particular task.
Are you telling me that I can use a Swarm inside a workflow?
Potentially, depending on if that particular use case is required for it, but yes.
Okay, this sounds great. Okay, then let's look at swarms. What are swarms? They are self-organizing autonomous teams, right? So they are collaborative teams that are able to collect multiple agents that work together as a team and solve a complex problem. So think of it as a brainstorming session where we are having experts who are building on each other's ideas with, to go to the best collective result. And that's where they shine, where it's a non-deterministic, complex task that you need to solve. This enables autonomous coordination between the agents with the shared context. So you have all the information that has, all the context that has happened so far. And there's you're sharing all the working memory with each other. so you don't lose up on any context and you don't repeat the same piece of information again.
And I would do, and when you're leveraging swarms, I would recommend leveraging this when you're wanting to enable that autonomous coordination between the different agents. So when it's really when you're wanting to make sure that you have a team of agents that can self-organize to be able to go in and solve a problem together. And you could leverage the swarm design pattern to really make sure that those agents have full access to the context tasks, a shared access to the working memory, and then they can leverage that collective intelligence to be able to go in to address that problem. And from a multimodal, I know there was a question earlier in terms of like multimodal model support. This would also be really good for when you're wanting to handle input support from a text, image, and other types of content types that may be needed in order to solve that particular task.
And just to clarify really quick, so swarms, can operate within an agentic, application, but could swarms one application talk to another application that has swarms as well in a kind of autonomous agent team way? And maybe is that where A2A comes in? Or maybe you're getting to that?
Exactly. You're jumping right ahead.
Very cool. Very cool.
And it's when they can, when they're just trying to decide when to hand off to another agent with a different expertise to go in and address that particular problem is really where swarms come in.
Now, I think, Jason, you might want to take this question really quick here, just really quick while we're on the slide.
Can you?
Yeah. So go ahead.
Oh, go ahead, Jason.
No, I was going to just read the question. So it says, can we cache context between swarm members, which is a really excellent point.
It depends on what you mean by caching the context. I mean, we do have context management, which provides the context to the agent member, to the swarm members. So this way we are sharing the entire memory with each other. But of course, to ensure that, the context window is not exploding, we are also summarizing some of it. So that context management is being taken care of by Strands. But for caching in particular, if you're talking in the model perspective, depending on which model you're using. But overall, from the framework perspective, it's mainly done from the session management and the.
Awesome. Great question. Great answer. Thank you.
Thank you. Okay, last one. I know you're keen on going to the demo, so I promise.
This is so awesome. What you guys have built here is amazing.
So the last one is the graph format, right? Where we have a deterministic workflow control to handle. A graph is, I'm sure most of you are aware of it, but just to define it, it's a deterministic directed acyclic graph, right? And it's the orchestration here is inspired by that. So where we have multiple agents or tools as nodes, and those nodes are executed according to edge dependencies. So the nodes are connected to each other via an edge. So the output from one node is passed as input to the connected nodes. It could be one or more connected nodes, right? And you use it when you want to enhance coordination, or you want to optimize for the task management, or you want to ensure that the flow is a bit more deterministic and consistent. So that's where this comes in. All right, let's dive right in.
Awesome.
And let's build. Before we go into code, just for context, I'll just go through the architecture of what we are going to build. Right. So we are going to use the agents as tools pattern, and we have a tutor agent that we have built. So now when the user interacts with the tutor agent is essentially going to talk to either a philosophy agent, if it's a philosophy-based question, or a math A2A server that we have built. Now, the math A2A server has 4 tools that are hosted in that server: add, subtract, multiply, just simple math operations that we have defined in there. You could, of course, add many more tools, of different subjects, but these are the 2 of my favorite subjects, so I just picked those. And the tutor agent is hosting within the same environment. It's hosting the philosophy agent, and it's connecting to the math A2A server via streamable HTTP support. Now, one thing to highlight here, A2A communication occurs over HTTP, right? Where all the request and response payloads that we are sending or receiving are formatted in a JSON RPC format. And because A2A is providing features like creating an agent card, this allows you to standardize the description of the agent capabilities. So it enables, multi-agent systems that are easily discoverable, and you can connect to other agents. And Strands auto-generates these agent cards based on the tools that you've defined in that agent. So this part is abstracted out for you. You can, of course, take control of that. You can define that. There's a way of doing it as well, but it's an added benefit. One more thing to highlight here about the transport, unlike MCP, so when you're calling an MCP, there you can use 3 transports, right? You can use HTTP, STDIO, and SSE, SSE being the server-side events. And for web-based, even there, HTTP is the recommended one, and STDIO for more local command line tunes. Okay, that being said, let's dive in.
Does it also work over WebSockets by chance?
I don't know if there's any direct support.
Gotcha.
SSE would be the closest to that.
Yeah. It's probably, yeah. Okay.
Okay, so this is our tutor. How we define it, we have our Strands agent. I added some more, extra things for coloring, etc. And first main thing here is we create a tool which takes in the Python function. Now that Python function, all that does is it takes in a question and implements and calls an agent. So this is the philosophy tutor that we have. And here we can define a system prompt. Here I just say, you're a philosophy tutor that helps the agent, helps the students, and returns the answer that the philosophy agent has returned. And this is the tool decorator that you see here is what defines that this would be imported as a tool, right? So that's what's transforming it as a tool. Now we have the A2A client tool provider. So before we go forward, let's look at what A2A, how we have defined our A2A agent. Okay, so this is an A2A server that we have built. Very simple approach that we have taken here. So we've defined 4 tools, and those 4 tools are being imported in the agent as tools. So as simple as that. And we define a name and a description of what this agent is capable of doing. Now we are wrapping this agent with an A2A server, which we imported from Strands multi-agent A2A. All we have to do is to wrap the math agent around with the A2A server and start the server. By default, we host it on the local host with the port 9000. You can change this as well if you want. And now going to the client side, where we have the tutor agent. So coming to the client side, we create a client tool provider with the known agent URLs. So we defined the local host with the port 9000, and that's what we add as our known server. Now we define the main agent, the main tutor agent, right? So here you see we define the provider.tools. So the provider as in the client that provides us with the tools from the server. And we add the philosophy tutor. So this is the agent as a tool. And that's all we add, and the rest is just for the just for the printing and execution. And main thing that's happening here is we are taking in the input, and we are calling the teacher agent with the user input and returning the response. So printing the response. Now let's look at it, how it works. So first thing we will do here is to execute our A2A server, right? So it was mathassistant.py.
And while you're doing that, I think it's something important to call out for those that may not know. What A2A is doing is wrapping an intelligent system, aka the agent with its tools, into the A2A server class. That's correct, right? And so it is different than MCP in that way, but they're complementary specifications.
Okay, so now we have the server running, and on the other side, I will just refresh my credentials, temporary ones, and we will go into running the tutor agent as tools. So it asks me a question. I can either ask a math question, hey, help me solve 2 minus 4 plus 42. So as you see, thing to highlight here is also that it creates the telemetry metrics. So all of the information that we have, all the logs are, all the traces are being collected. So you can use them. And let's see if it called. Okay, so here we see it did get a call from the agent. So it did calculate 2 minus 4 first, and then did the second calculation of addition. So it used two tools. Going back to the client side, it called the tool with the A2A send message through the app, and then it solved the expression and answered the question. So the blue part is the final question. Right? Now, to make it a bit more interesting, let's take another approach. This is a more fun way for me. I was just, I don't want to say sitting idle, but I was just feeling a bit fun.
A bit more creative.
Bit more creative. Thank you. Okay, so another approach we can take to this is taking a more workflow approach, right? Making it a bit more deterministic. So we have the same A2A server that we have. Again, same process, created the client, but this time I do not want to add my philosophy agent in the tools. So this time I want to add my philosophy agent as a sequential step after the math agent has executed its task, right? So what we do there is we have the teacher agent, user input, as we did before. So that's going to be the step one. So once we get the response from the teacher agent, we're going to pass it into the philosophy agent as an input. And I added some extra prompt saying, hey, interpret this response philosophically with humor, because why not? So let's now try this out. Okay. This is tutor workflow. Okay. I will ask same question. No, wait. Help me solve, what was it? 4 minus 4. Okay, let's keep it simple. Help me solve 4 minus 4.
Can it divide by 0?
What did it do? Okay, it discovered the agent and it did return 0. So we are on the right track. Now let's see what does our philosophy agent says. My dear student, you have stumbled upon one of the universe's greatest cosmic jokes, 0. That magnificent mathematical nihilist. So you see, you can,
That's
depending
awesome.
on what you want to build, you can do anything you want. You can make any combination, anything. And right now we showcased an A2A, right? You can also do the same with an MCP server. So in a similar fashion, you can import, the MCP client, add it in the same. We are sticking to the same format with the HTTP, and as we did with A2A server, we define these as tools. Here we create, the MCP server first with some description, and we register those tools. So tool number 1, 2, 3, 4, as it was, and then third step would be to do mcp.run with the transport that you want. And in here you can have stdio, SSE or stream or HTTP. And then once we have defined our MCP, we will call this and we will start this server in a background thread. Now we create HTTP client and basically use it for the agent. So we list the tools and the agent can import those tools. So the tools we create here in that HTTP client, we can import as tools in this agent, and this is going to be our math agent. So it's ready to go. And this you can import again within the client. And
so basically what you're showing here is that how versatile Strands is. Like you can have literally agent to agent communication with the agent's own intelligence, own prompts, own systems, or own tools. And then you can also still, of course, use MCP to access data as well. So, I mean, this is really awesome. I mean, is it okay if we take one question? I know we're pretty close on time here. It looks like we have a question from Adrian. Does increasing the number of tools available make it more difficult for the LLM to choose an optimal tool?
that's generally true, but it's a thing of how many tools we are talking about here. So of course, if you're talking about hundreds of tools, it gets complex, and there's hallucination. There's chances of hallucination, and this has nothing to do with a certain framework or a certain model. It's a general statement, I would say.
That said, though, what we just announced Amazon Bedrock AgentCore Gateway, which is one of the services that you can leverage to enable your agents to leverage thousands of tools and to be able to go in and make the appropriate selection based on the context that you're giving it in a secure way. So it is a challenge for a variety of different developers, and that's one of the approaches that you can leverage to really get the most out of enabling your agents to discover and connect to the appropriate tool at scale, so it doesn't necessarily impact your latency and accuracy for addressing that particular task.
Well, you've already mentioned it, Amanda. Do you want to quickly?
Of course. So
Less
yes,
than a minute left.
Yeah, last minute. So we just recently announced Amazon Bedrock AgentCore, which is to fundamentally address these broader problems of getting your agents to production, and it is addressing those key issues. And because we don't have a lot of time left, we're going to be reviewing Amazon Bedrock AgentCore next Tuesday night. And we're going to talk through a variety of different AgentCore services that address and tie together what you need in order to bring agents to production. So you're not just building them on Strands, you can also bring those agents to production securely, leveraging a secure runtime being able to go in and remember past interactions with memory.
That's awesome. Well, Amanda, Karsha, thank you so much for this. I know we're up on time here. Jason Stinson as well. Thank you for co-hosting.
Thank you.
Yeah. Appreciate everybody for watching. And we'll have the links for some of those resources within the YouTube channel as well. So thanks again.
Thanks, everyone.